Section 2.2, Objective 1, use the addition and multiplication properties of equality to solve linear equations. So our first example, we're going to solve the linear equation 3x minus 9 equals negative 24. So our step 1 in solving this is we need to isolate the term involving the variable. In other words, we want to get the variable expression by itself. The variable expression here is the 3x. So that's our first step, is to kind of just isolate that term of 3x. So let's write down the whole equation right here. 3x minus 9 equals negative 24. So first thing to isolate the 3x is I'm going to add 9 to both sides. And that's going to give me 3x equals negative 15. Now that we have isolated the term involving the variable, we're ready for step 2. We're going to get the coefficient of the variable to equal 1. Get the coefficient of the variable to equal 1. So I'm going to copy down once more what I ended off with. I ended off with 3x is equal to negative 15. To isolate the x, we will need to divide both sides by 3 or multiply by 1/3. 3 divided by 3 is just going to give me a 1. So I will be left with x is equal to negative 5. Okay, now we're not done here. Remember, there is a final step that we need to do. Our final step here is going to be we need to check. So we need to check our solution. The original equation was 3x minus 9 equals negative 24. Every time you see an x variable, you're going to substitute negative 5 in place of x, and we're going to see if we end up with a true statement. 3 times negative 5 is going to give me negative 15, and negative 15 minus 9 is actually going to equal negative 24. Negative 24 is equal to negative 24, so therefore this is a true statement. Our final answer here will end up being the solution set of negative 5. Let's do another example. Let's solve the linear equation 5/4 x plus 2 equals 17. So let me go ahead and copy that equation one more time right here. So we remember we want to isolate the term with the variable. So this is the term with the variable. So we're going to isolate that term. So first thing we want to get rid of is the 2. The 2 that's being added to that variable expression. The opposite of adding 2 is subtracting 2. So I'm going to subtract 2 from both sides of the equation. So this will leave me with 5/4 x is equal to 15. Okay, now we're ready to isolate the x. So we are going to multiply by the reciprocal of 5/4. The reciprocal of 5/4 is 4/5. I'm going to write a 1 under the 15 so it's clear to me what is in the denominator. 4 times 5 is 20, and 5 times 4 is 20, which is going to leave me with a coefficient of 1x. 20 divided by 20 is 1, and I don't need to write down that 1. Over here, 15 times 4 is going to give me 60, and 1 times 5 is 5, and 60 divided by 5 is 12. So our solution for this looks like it's going to be a 12. But before we actually um, say that that's our solution, we should actually check it to be on the safe side to make sure we didn't make any mistakes. So let's do a check. So this is going to be 5/4 times x. In this case, x is going to be 12. I'm going to write 12 over 1 plus 2 equals 17. So 5 times 12 is going to give me 60. 4 times 1 is 4. Plus 2 is equal to 17. 60 divided by 4 is 15. And 15 plus 2 is going to give me 17. 17 is equal to 17. So since this is a true statement, then that means that yes, this is our final answer. 12 is the solution to this equation. Section 2.2, Objective 2. Combine like terms and use the distributive property to solve linear equations. So for our next example, we're going to solve the equation 4x plus 9 plus 2x equals negative 9. In this problem, we are going to combine like terms. So in this case, we have 4x and 2x, and both of these are like terms. So I'm just going to rewrite them so that they're right next to each other. You don't have to do this step. You could just, if you could do this in your head, then you could just write down the answer here. Okay, so 4x plus 2x is 6x. Now we're ready to isolate the term that contains the variable. So I'm going to subtract 9 from both sides. And that's going to give me 6x is equal to negative 18. Now we're ready to isolate the variable. So I'm going to divide both sides by 6. 6 divided by 6 is just going to give me a 1. And x is going to be equal here to negative 3. Remember, you're never truly done until you check your answer. So now we're going to check this to make sure that we have the correct answer here. So our original equation was 4x plus 9 plus 2x equals negative 9. It's always a good idea to use the original equation, not the one where you already combine like terms, because just in case you didn't combine like terms correctly, this is where you're going to catch it. So I'm going to substitute here negative 3 for every time I see an x. Four times negative 3 is negative 12 plus 9, and then 2 times negative 3 is negative 6. Negative 12 plus 9 is going to give me negative 3, and negative 3 minus 6 is going to be equal to negative 9. So this is true. Therefore, that tells me that negative 3 is the solution to this equation. So I'm just going to go ahead and write it as a solution set inside a set of braces, and that's it. We're done. All right, let's do another example. This time we are going to solve the equation 3 times the quantity 4y plus 1, minus 4 equals negative 13. Let me rewrite that equation right here. First thing we have to do here is we need to use the distributive property in order to remove these parentheses. So I am going to distribute this 3 to both of the terms inside of the parentheses. Let me try that arrow one more time. There you go. 3 times 4y is going to give me 12y. 3 times 1 is going to just give me 3. I can now drop the parentheses. Now I can combine like terms. My like terms here are going to be the 3 minus 4, or 3 plus a negative 4. That's going to give me minus 1. Now I can isolate the term with the variable in it. So I'm going to add 1 to both sides. And this is going to give me 12y is equal to negative 12. Now I'm going to isolate the variable by dividing both sides by 12. I'm dividing by 12 because of the 12 that's in front of the variable. That's why I'm dividing by 12. 12 divides into 12 one time. So we're just going to be left here with 1y is equal to negative 12 divided by 12 is a negative 1. So it looks like my solution is going to be negative 1, but to be on the safe side, we need to check our answer. So let's go ahead and do that right over here. Let's do the check. We always check back into the original equation, just in case we might have made a mistake when we used the distributive property, or maybe we might have made a mistake when we combined like terms. This is the way you're going to catch it, by using the original equation. So we're going to substitute negative 1 in place of y right here. Everything else is going to stay the same. Four times negative 1 is going to give me negative 4. Working inside the parentheses, remember we follow order of operations, grouping symbols first. Negative 4 plus 1 is going to give me negative 3. 3 times negative 3 is negative 9. And negative 9 minus 4 is negative 13. Negative 13 is equal to negative 13. This is a true statement. Therefore, yes, negative 1 is the solution to this equation. Okay, very good. Section 2.2, Objective 3. Solve a linear equation with the variable on both sides of the equation. For this example, we're going to solve the equation 3x minus 8 equals 2x minus 15. Notice that we have an x term on both sides of the equal sign. We need to get all of the x's to one side of the equal sign. I'm going to choose to move the 2x as a negative to the other side. So I'm going to subtract 2x from both sides of the equal sign. These are going to cancel out. And notice here that now I will end up with a positive 1x on the left-hand side. I always like to try to keep my x term positive whenever possible, so that I don't have to worry about multiplying or dividing by a negative later on, because there's always a chance you might make a mistake if you're not good with working with your negatives, with multiplying and dividing. So if you're one of those people and you think there's a chance you might make a mistake, try to keep your x term positive if you think that might help you with your algebra. Alright, now I'm going to isolate the x by adding 8 to both sides. So this will give me x is equal to negative 7. Right? Before we decide whether or not that's our final answer, we should always take the time to check our work. So now I'm going to go back and check my work using the original equation. Every time there was an x in the original equation, we're going to substitute that with a -7. Everything else stays the same. That doesn't look very good. Let me try that. Negative. There. Good. 3 times -7 is -21 minus 8. That's going to give me -29. 2 times -7 is -14 minus 15. That's going to give me -29. Therefore, this checks out. Yes, -7 is the solution to this equation. All right, let's solve another problem here. We're going to solve the equation 12 minus 2x minus 3 times the quantity x plus 2 equals 4x plus 12 minus x. Okay, I want to make sure you can see that x in there. I'm not sure if, let me just minus x. I think that might be better. All right, first step. Step 1. We are going to remove the parentheses using the distributive property. Okay, so let's go ahead and write our equation over here. Our equation was 12 minus 2x minus 3 times the quantity x plus 2 equals 4x plus 12 minus x. We're going to use a distributive property, so I am going to distribute a -3 to both of the terms inside of the parentheses. So that's going to give me 12 minus 2x minus 3x minus 6 equals 4x plus 12 minus x. Good. Now we're ready for step 2. Step 2 is going to be to combine like terms. Our like terms here in this case would be the -2x and the -3x. We can combine those two together, and also the 12 and the -6. Those can be combined together. On the opposite side of the equal sign, we can combine the 4x and the -x together. All right, so we're going to have 12 minus 6 together, and then the -2x minus the 3x together. And I'm going to put 4x minus x together, and then the 12 here at the end. 12 minus 6 is going to just give me a 6. -2x minus 3x is going to give me a minus 5x. 4x minus x is going to give me 3x, and then I'll just write after that one plus 12. All right, step 3. Step 3 is we're going to use the addition property to get variables on one side and constants on the other side. So that's addition property. To get variables on one side and constants on the other side. Six minus 5x equals 3x plus 12. I'm going to go ahead and move the negative 5x as a positive 5x, so that way I can have a positive x term. And then I'm going to move the 12 here as a negative, so minus 12 minus 12. These will cancel, these will cancel, and we'll be left with negative 6 is equal to 8x. Step 4. Step 4 will be to use the multiplication property to get a coefficient of 1 on the variable. So that's multiplication property to get coefficient on variable to equal 1. So we had negative 6 is equal to 8x. So we're going to divide both sides by 8 because that's what's being multiplied to the x. You want to do the opposite to get that 1 in front of the x. So now here, negative 6/8, we can actually reduce that. 6 is the same as 2 times 3. 8 is the same thing as 2 times 2 times 2. We can cancel out a common factor of 2, and then that's going to give me a negative 3/4, and that's going to be equal to my x. Next part, we get to check it. Step 5, we check. All right, so this is going to be a few steps here. I'm not sure if it's going to fit into this box, but we're going to try to get it to fit in here. Using the original equation was 12 minus 2 times, and this is where we put in the what we believe to be the solution. So in this case, negative 3/4 minus 3 times the quantity, and then there goes the negative 3/4 plus 2 equals 4 times negative 3/4 plus 12 minus a negative 3/4. Barely got it to fit in the box. Now we get to simplify all of this. Yay! 12 minus, I'm going to write this as 2 over 1 because I'm going to have to multiply it with a fraction. And here I'm going to write this 2 in the parentheses as a 2 over 1 because I'm going to have to get a common denominator, and I can already tell that that common denominator is going to have to be 4. I'm going to have to multiply by 4 to the numerator and denominator of that 2. Equals, here this 4, I'm also going to write this 4 as 4 over 1 because I'm going to have to multiply it with a fraction. And a negative times a negative here turns into a positive, so I'm going to write plus 3/4. So this will give me positive 6/4 minus 3 times, this will be negative 3/4 plus 8/4 equals negative 12 over 4 plus, I can already tell that my LCD here is going to have to be 4, so I'm going to write a 1 here so I can get that LCD of 4, and I'll just write here that I'm going to have to multiply by 4 to both of these, the 12 and the 1. Alright, let's go back to the left hand side. I can already tell that I'm going to have to be working there with an LCD also of 4, so I'm just going to have to write this 12 here. I'm going to just already start writing, setting it up for that to have that common denominator of 4 plus 6/4 minus 3. I'm going to write 3 over 1, and I'm going to have to multiply that with what's inside the parentheses, negative 3/4 plus 8/4. That's going to give me 5/4. So I'm going to write there 5/4 equals, this is going to be negative 12/4 plus 48/4 plus 3/4. All right, we're almost there. This is going to be 48/4 plus 6/4 minus 15/4 equals negative 12/4 plus 48/4 is going to give me 36/4. And 36/4 plus 3/4, I might as well just finish that. That's just going to be 39/4. Over here, we're going to have 48 plus 6. That's going to give me 54/4. And then 54 minus 15. Well, that's just going to turn out to be 39/4 as well. So it looks like the check works out nicely. So now we are confident that our final answer for this problem is going to be negative 3/4. There, negative 3/4. All right, a quick little summary of all the steps we just did. Summary. Step 1, remove any parentheses. Using the distributive property. Step 2, combine like terms. On each side of the equation. Step 3, use the addition property of equality. To get all the variables on one side, and all constants on the other side. Step 4. Use the multiplication property of equality gosh, I think, let me write equality because I don't think it fits there. Multiplication property of equality. Multiplication property of equality to get the coefficient of the variable to equal 1. Oh, get the coefficient of the variable equal to 1. Yeah. And then step 5, check the solution. To verify that it satisfies the original equation. Good. That's it.